Hi guys, welcome back to my channel. You know that I've already started ionic bonding and I taught you what is meant by the term ionic bonding and different types of chemical bond. Let us start the continuation of the same topic. So you know that I have discussed in my previous video what is meant by the term ionic bonding. It is a type of bond formed between metal and non-metal. Now see, what are the factors which affects the formation of the ionic bonding, or we can say the favorable condition to form the ionic bonding. And we know that it is formed between metal and non-metal. So metals and non-metals. Metals, metal and non-metals. Metal mostly lost electron, metal lose electron and non-metal gain the electron. So look at that. Metal has to give away the electron and a non-metal has to gain the electron. Now look at this size. Let's see the size. When you look at the elements in the same group, like for example lithium, sodium, rubidium, lithium, sodium, my bad, potassium, lithium, sodium, potassium, rubidium, cesium, francium. What happens when you go down the group? Atomic size increases. When the atomic size increases, the force of attraction between this new nucleus and the outer shell electron decreases. So it's easy for the element to give away the electron. The one which lose the electron easily make a strong ionic bond. So when you move down the group, atomic size decreases. So to make the ionic bond, we want we want a larger cation. So it's formed between the cation and anion. First, they give away the electron. So when you move down the group, the tendency to lose the electron increases. Which one gives away the electron easily? Cesium. Francium is the radioactive element. Just ignore francium. So focus on cesium. Cesium. And how can we take away the electron? Can a metal give the electron by its own, or do we need to give energy to a metal to lose the electron? Yes, we have to supply some energy. We have to supply some energy to a metal so that it gives away electron or it loses the electron. Any idea what we call that energy? It is called ionization energy. I will teach you in my separate video what is meant by the term ionization energy. Anyway, it's the amount of the energy needed for a metal to lose the electron. Okay. And ionization energy should be low, because when you move down the group, size increases, ionization energy decreases. So condition, small condition, size of the cation, size of a cation be bigger size. So when you move down this group, atomic size increases. So the metal which is easy to give away the electron is the last metal when you move down the group. So size of a cation should be bigger. Now let's take the example of halogen, fluorine. Take the example of halogens: fluorine, chlorine, bromine, iodine. This group element has to lose the electron and this group element has to gain the electron to make a ionic bond. Okay, fluorine will gain electron. So fluorine can gain electron by itself? No. I mean, fluorine can gain electron by itself. When a fluorine gain an electron, it releases an energy. That energy is called electron affinity. We will do it, guys. So two energy terms we used. One is called ionization energy. ionization energy for metals, amount of the energy needed to take away the electron. And one more energy term I'm discussing here is electron affinity, EA value. So it is the amount of energy released when an electron is added to a neutral gaseous atom. Okay, EA. EA should be maximum, because when a bond is formed, its energy decreases. Mean when ionic bond is formed, some amount of energy coming out. It's a type of exothermic reaction. That energy is called lattice energy. We will discuss in my separate video. Enthalpy of lattice or lattice energy. Okay, so max EA, minimum ionization energy. Two condition. What's the condition? Less ionization energy, min ionization energy, minimum min IE ionization energy, max EA, and larger size of the cation and a smaller size of the anion. So remember that one, SALC. What's SALC? SALC. What's SALC? Smaller the anion, larger the cation. So we are discussing in the same group. When you compare, I will give you, look at this question. Which one of the following has maximum ionic? Which one of the following has the maximum ionic bond percentage? So we didn't get it. So you're confusing. Mean no ionic compound is 100% ionic, or no covalent compound is 100% covalent. All the ionic bonds, they have some percentage of covalent character, and all the covalent bonds have some percentage of ionic character. And they will ask this type of question, or you will come across this type of question in the examination. Look at that. Like NaCl, KCl, RbCl, CsCl, cesium chloride. So chlorine is same. So I told you, follow SALC. SALC. We want larger cation and smaller anion. Anion is same. Ignore that. Chlorine, 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 chlorine. What happened to the atomic size when you move down the group? Lithium, sodium, potassium, rubidium, cesium, francium I'm not taking. When you move down the group, atomic size increases. So when atomic size increases, the ionization energy decreases. It is the amount of the energy needed to take away the electron. So which one gives the electron easily? Cesium. So cesium chloride has most ionic percentage or most ionic bond. No doubt all are ionic, but not 100% ionic. So cesium chloride is the right answer. We will do one more question. Like NaF. Look at this question also. Which one is most ionic? NaF, sodium fluoride, NaBr, NaCl, NaBr, sodium bromide, NaI. Which one is most ionic? Follow this thing. For non-metal, metal is same, so ignore sodium. For non-metal, smaller the anion. Which one is the smallest? Fluorine, chlorine, bromine, iodine. When you move down the group, atomic size increases. We want the smallest one. This is the smallest one. So most ionic is sodium fluoride. Okay, that's fine. If we have this type of the question, mean they're giving you within the same group. Suppose look at this question. I've seen this question in many past paper, especially OCR and AQA. Look at that question. Which one of the following is most ionic? Look at that question, guys. How to work out for that question? Look at that one. So they will give you NaCl, MgCl2. Why MgCl2? I will tell you why the formula is MgCl2, NaCl, my bad, NaCl, MgCl2 and AlCl3. So we can't use this technique SALC. Now we have one more thing. Since ionic bond is a type of electrostatic force of attraction between the two oppositely charged ions, we have one formula which we use for electricity. Those who are doing physics, we have a formula for forces. When there is a oppositely, when we have two oppositely charged ion, how can we work out the force? The force we worked out as Q1, Q2 by R square, or in some books it is given as D square. Q1 is the size of the cation, Q1 is the size of the anion, and this is the interatomic distance. Well, sir, what is interatomic distance? This one. This one is the interatomic distance. This is the R and R, that's called the interatomic distance. So smaller the distance between the two atoms, greater will be the force. We applied this formula to work out that one. Q1, Q2. Okay. So we have to work out the magnitude on the charges. What does it mean, sir? Na plus, look at that. Chlorine is same. Just ignore the chlorine. So we have Na plus, Mg2 plus, and AlCl3 plus. One thing, smaller the... Now, we can't use the larger cation and a smaller anion, this technique. What we are working out, check the magnitude of the charges because of force of attraction. Q1 and Q2. More the magnitude, more will be the attraction. So which one has the more magnitude? Aluminium. So aluminium chloride has maximum percentage of ionic character. When you use this formula, because of the small size and the R is less. So Q1, Q2 and their magnitude. Which has more magnitude? Aluminium. So aluminium chloride has more percentage of ionic character. This way you can work out which compound has more percentage of ionic character or most ionic. Okay. Now, some of the students, especially the GCSE student, they're getting confused how when we ask to write the chemical formula of certain ionic compound. Let's see. I will show you the easy technique to write the formula of an ionic bond. How, sir? Let's see. Then we will discuss the properties of ionic compound. So just now I taught you how to work out the percentage of ionic character in the given ionic compound. Mean which one is most ionic. One, you can use this arc if you are in the same group. Otherwise, use force equals to Q1, Q2 by R square. Smaller the radius between the two ions, or the magnitude. Okay. Now we will learn how to write the chemical formula of an ionic compound. Let's see. Just now I have written on my bad. Okay. Sodium oxide. First one. Write down the chemical formula of a sodium oxide. Okay. All right. Down. The chemical formula of an ionic compound. A. Sodium oxide. B. Calcium chloride. C. Calcium oxide. D. Aluminium chloride. E. Aluminium oxide. You know that? Oxide. A non-metal, when it gains an electron, we have to name it as ide at the end. So we didn't get it, sir. No worries. Fluorine, chlorine, bromine, iodine. When fluorine gain one electron, it becomes fluoride ion. When chlorine gain an electron, it becomes chloride, bromide, iodide, oxide, like that. Now, can you write the formula of a sodium oxide? And we know they will ask what type of, for GCSE, they will ask what type of a chemical bond present between sodium oxide. Yes? Tell me what type of chemical bond present in the sodium oxide. Check. Sodium is present in the extreme left side of the periodic table, and a sodium being a metal, and oxygen is a non-metal. We know that. So what type of chemical bond is present between metal and non-metal? Obviously, ionic. Let's see how to write the formula of an ionic bond. Sodium, we know sodium. Before that, okay, copy down that question. Before that, we will check which metal give away one electron, which group element lose one electron, which group element lose two electron, which group element lose three electron, or which group metals gain 3 electron, gain 2 electron, gain 1 electron. Let's see before that. Please copy down that one and we will see that one first. Look at that. Group 1. Group 1, lithium, sodium, potassium, rubidium, cesium, francium. Group 2, group 2nd or group 2? We can say group 2nd elements. Group 2, mostly metals, beryllium, magnesium, potassium, calcium, strontium, barium, radium, Ra. Okay. Group 3rd or group 3, metals, boron, aluminium, gallium, indium, Th or Tl, thallium. Okay. I'm not showing you group 4 elements. Group 4 elements mostly form covalent compound. Just leave it. Boron, aluminum, gallium, indium, thallium. Okay. Now, group 5 or group 15, same thing. Group 5 or group 15. Nitrogen, phosphorus, arsenic, Asb, bismuth, antimony, bismuth. Nitrogen family, group 5 family, or group 15, group 6. Oxygen, sulfur, selenium, tellurium, polonium. So when we move down the group, metallic character increases, guys. And last one, halogen. First of all, why those compounds form bond? I have already discussed in my previous video 2 factors. One, to get the stability or to get the 8 electron in the outermost shell, which is also called as octet law, octet rule. Okay. Fluorine, chlorine, bromine, iodine, astatine, which is the radioactive. Okay, so mostly these are metals and these are non-metals. The basic tendency of the metal is to give away the electron. Group 1, why all these elements are placed in group 1? Reason behind, it has one electron in the outermost shell. So for those elements, it's easy to give away one electron. So they can give away one electron, they lose 2 electrons, they lose 3 electrons. They have 2 electrons in the outermost shell, they have 3 electrons in the outermost shell. Now, look at that. They have 5 electrons in the outermost shell. What we call the electrons which are present in the outermost shell? Valence electron. They have 5 in the outermost shell. To get 8 electrons, they have to gain 3. So they can gain 3. When a non-metal gain an electron, it got a negative charge. So gain 3, this is called the valency. Gain 2, because they have 6 electrons in the outermost shell, that's why they are placed in the group 6. Gain 1, they have 7 electrons in the outermost shell. It's easy to gain 1 electron rather than lose 7 electrons. Okay. This is also called electrovalency. Electrovalency never be a positive or never be a negative. What is meant by the term electrovalency? It is the ability to gain or lose the electron. That's why ionic bond is also called an electrovalent bond. Ionic bond is also called as electrovalent bond, because it all depends on its electrovalency. What is electrovalency? The ability to gain the electron or to lose the electron. Now, with that, can we write the formula of sodium oxide? Yes, please copy down that one. Very important. You can't get this type of explanation in any textbook. So can you try? I want to give the homework for writing the chemical formula of sodium oxide. Calcium chloride, calcium oxide, aluminum oxide. Look at that. Based on that, mean how many electrons they can lose or they can gain. With that, electrovalency is the ability to gain or to lose the electron. We can write the chemical formula of any ionic compound in the periodic table. Thanks for watching this video. I will come back with my new video. Bye.